Hello. Hello and welcome. I'm Author Blues, and we're doing Advent of Code Day 12, which is the last day. This is it for us. I can see I never made the switch to C that I was considering making, but that's fine. I never got the part 2, no. I never went back to it. I may go back to it in the future. Not like on stream, but I may go and figure out what I was missing. Share the problem with some people who are smarter than I am and maybe get some insight into it. I'd like to figure out what I had done wrong, but... Anyway. Day 12. Let's jump in. Day 12. Christmas Tree Farm. You're almost out of time, but there can't be much left to decorate. Although there's no stairs, elevators, escalators, tunnels, chutes, teleporters, fire poles, or conduits here that would take you deeper into the North Pole base, there is a ventilation duct. You jump in. After bumping around for a few minutes, you emerge into a large, well-lit cavern full of Christmas trees. There are a few elves here frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents for all the young elves that live here at the North Pole. An ancient tradition to put the presents under the tree. It's an ancient tradition to put the presents under the trees, but the elves are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and the regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents need to be placed into the regions in a way that follows a standard two-dimensional unit grid. You also can't stack presents. As always, the elves have a summary of the situation, your puzzle input for you. First, it contains a list of the present's shapes. Second, it contains the size of the region under each tree and a list of the number of presents of each. So this is, it's space packing. The first section lists the standard present shapes. For convenience, each shape starts with its index and a colon. Then the shape is displayed visually, where # is part of the shape and period is not. The second section lists the regions under the trees. Each line starts with the width and length of the region. 12 by 5 means the region is 12 units wide and 5 units long. The rest of the line describes the presents that need to fit into that region by listing the quantity of each shape of present. One present with shape index 2, blah blah blah. Presents can be rotated and flipped as necessary to make them fit the available space, but they always have to be placed perfectly on the grid. Shapes can't overlap. That is, the hash part from two different presents can't go in the same place on the grid, but they can fit together. The elves need to know how many of the regions can fit the presents listed. In the above example, there are 6 unique present shapes and 3 regions that need checking. The first region is 4 by 4. And then you need to determine whether you can fit 2 presents that have the shape index 4. After some experimentation, it turns out you can fit both presents in this region. Here is one way to do it, using A to represent 1 present. Yeah, that makes sense. Second region is 12 by 5. It's 12 units wide and 5 units long. In that region, you need to try to fit 1 present with shape index 0, 1 with shape 2, 2 with shape 4, and 2 with shape 5. Turns out these presents can all fit in this region. Here's one way to do it, again using different capital letters to represent the required presents. So what's the largest region we're dealing with? Okay, that's harrowing. Um, 160 something slots. 2,500 different locations. Each shape is going to have rotation. So 4 different rotations with 2 different flips each. So each present needs to be checked 16 different ways. But you don't really have to check it 16. I mean, yeah, I guess you do. Man, that's rough. What were they thinking? With... Are the presents always 3x3, or are there larger ones? Always 3x3. Is there anything clever you can do with that? I feel like there's... I mean, if this is just like an annoying problem, that's fine. I can code up annoying problems, but this feels both annoying and probably potentially intractable. Well, not intractable, just slow. Don't hope for much from me. Okay, so trying to streamline the process of this a little bit, rather than doing it with like some sort of list method. or string methods. Okay, so that's the problem statement. Done. I still need to figure out how to rotate a shape in this paradigm. Rotate and flip. Flipping's easy. So maybe building a helper method would work for me. So I have my shape, which is just a list of locations. If I rotate it once, I mean, I could do this recursively, but I don't think that's going to be fast. I've heard of it. I've heard of math. There's gotta be a regex that does this. Genuinely, I hope not. I genuinely hope there is no regular expression that can solve this. So number of times I'm rotating is going to be... so to rotate once, I'll consider it rotating it clockwise. That would mean that... new shape equals... something for RC in shape. So what is the manipulation here? My column number becomes my row number. And my row number gets flipped, so it's 2 minus row. Ironically, I don't really have to get this right, because the fact that I'm also allowing for flipping horizontally and vertically means that even if I fuck up this math, it's all fine. My row number... So what row this is at becomes its column number, but it flips. So the last column becomes the first... Sorry, the last row becomes the first column. That's correct. And then my previous column number becomes my row. I think that's right. That looks right to me. Return manip of shape, no, new shape, and rot -1 and H and V. So if we're flipping this horizontally, I guess I can do this all at once. Okay, I don't have to do this recursively. Okay, so that's doing all the rotations. Then if I want to flip it horizontally, then shape equals so flipping it horizontally would just mean reversing the and flipping it vertically is just flipping the row numbers. I'm trying to make this as lean as I can because this is going to get called a fuck ton of times. But some of these are redundant, like rotating twice and flipping once, horizontal or vertically, is the same as just the same as flipping horizontally. Can I represent all rotations as just... No, not necessarily. There's 8 states, so only 3 bits are needed. So what are the 3 bits? 1 rotation, 1 horizontal flip, and 1 vertical flip, and that covers all scenarios? If I just implement those 3 things, is that enough? Like 1 rotation, 1 horizontal flip, and 1 vertical flip, does that cover all? And flip diagonal. Really? Flip diagonal? Like across either the major or minor diagonal? How do you flip across the main diagonal? It's just... invert the... Isn't that just inverting the row and column? I think that's just inverting the row and column. Okay, well, we'll see. We'll see if that works. For... Okay. So, this is like... This feels like it's a recursive problem. Can I implement this without doing recursion? I feel like if I try to implement this without doing recursion, I'm going to make my life more annoying. I can basically implement this as a stack, though. Yeah, I think I need to do this recursively. Correct, so that is what would happen if you flipped something diagonally. Is that things on the major diagonal would stay along the major diagonal in the exact same spot. Solve. Do I actually want to build a grid? I feel like I want to build a... I actually may not need the grid itself, though. I can fake the grid in the exact same way. Oh. Oh, my grid can be a set. Oh, this is actually quite nice, I think. 0. Determine what you get when you solve for counts I plus 1. Otherwise, we're going to place every possible configuration of this piece at every possible location and see if any of them give me a solution. I think I want to build these pieces out one time in advance. There's a better way to write this. I'm not going to bother. Okay, so for each present now, we have all the possible configurations of it. That's a lot, man. Oh well. Y in range 0 up to... height -2. I think I actually want height -1 here. No, I think I want height -2. We're seeing what we can do. Thanks for gifting that sub, Implied Kappa, to try math. You know what? I'll try math. So we've got the configuration, we've got it transposed.
Never give up.
That's right, no backseating. If it's in the grid, I don't even need to do this. I can just look at the intersection. Isn't there shorthand in Python? For this, it's like, there's a symbol for it. I mean, I'm just trying to do intersection, but there's like a single character symbol for this, and I can never remember what it is. Because that's just not a normal thing in Python, but... Okay, it's just and. Is there like an efficient way to test the I mean, I could just do len, I guess. No, I mean, I do understand it, but it can be a little bit confusing. Uriah, thank you so much for the resub. We have not hacked the planet yet, so if this would put it at any place where there's already something in the grid, we skip it. Otherwise, I'm going to first union with tconfig. Then I'm going to call solve. If solve counts God, I don't want to make a copy or modify that list. I think that's going to mess me up. And then there's difference. Yep, minus equals tconfig to remove the configuration that I added, and then we can move on to the next one. I think this is going to be too slow. Here, this is my hot take. I think this is going to be too slow. Though this can be a set too. I mean, it doesn't really hurt anything. In fact, I think it needs to be for the way I'm doing this. I'm doing none of that. Why are we at 5-1 ever? Am I missing something here? Oh, we're on the second case? Oh, it finished the first one instantly. Oh, okay. This is still too slow then. I understand now. This is too slow for the sample.
Determined to go forward.
Blue Thunder, thank you so much for the resub. So there's a few clever approaches I could take to maybe speed this up. I don't like them. I don't like what I would have to do the speed ups I'm thinking of. Hey, Derek. There's once again like an easy observation I'm certainly missing here for even the first half. So you could represent these rather than as like sets of tuples. You could represent these as like bit fields. Transposing it becomes a lot easier with bit fields, because then it's just bit shifting, which is fast with a computer. The problem is that rotating in a bit field's annoying, and as an added bonus, the actual inputs are quite a bit larger, though they are smaller than 64. So you could, I don't know if Python uses 64-bit integers, but I imagine it does. So each row can be represented as a bit field. I would just have to implement rotations in that bit field. But as long as you pre-compute them, I don't think that's a problem. Like, you can be as slow as you want to, as long as you're pre-computing them. I'm a little worried I might need to go this route. I'm trying to think if there's any other optimization here. Because trying to think if there's any other optimization here. I think bit fields are probably... Well, no, I understand that. I know that they sort of silently swap to big integer. I'm talking about their default configuration beforehand, which would make a difference if I'm doing bit twiddling. But I think it would be faster. The problem is I think it would be faster slightly. I think there's still an observation I'm not making here to speed things up, to like narrow down my search space. Because right now I'm taking every present and I'm just sliding it across the whole world trying to find every location I can put it. Like, there's certainly a few observations to be made here. For instance, like this present right here, actually several of these presents, right? Like this one right here is symmetric in every direction. So you can reduce the number of configurations you need to worry about. This one's symmetric across the diagonal. This one's symmetric horizontally and vertically. This one's symmetric vertically. This one is symmetric, well, both rotationally and vertically, or rotationally and diagonally. And so you can lower the number of configurations you're checking. I don't think you can use... Like, I could delete the duplicates by using a set, technically, but since I'm pretty sure sets only accept immutable types, this won't really work. But I could do some stuff to make sure that I'm not getting any duplicates, at least. Let's look at a few small speed-ups before we jump into the big time. Yeah, for quite a few of these, there's actually very few duplicates, which instantly sped things up. Probably not enough to be able to solve the first problem in any reasonable amount of time, but it sped things up. This one found a configuration early and was done. But because the other one we know can't be solved, it has to go through a lot more. I'm still on I'm still on part 1, but the n squared print. I'm not sure what n squared print you mean. Okay, so I think my next step to really improving this is to do this as bit fields. I don't love it, but okay, my new shapes have arrived. Oh good, this VOD will get ID'd by Raphael Borba again. So now it's not this anymore, it would be... How do I want to write this? For R in... Does Python have like a break high feature? Did they ever make that work? Oh, I guess technically. You could do like a for else to accomplish that, but that sucks. Man, I wish Python would just add targeted braking. if, sorry, I'm like blanking right now. If, if grid R plus Y and row left shifted by X. I'm basically doing this in reverse, it's fine. Probably. I don't see a reason why it wouldn't be, but it's probably fine. I don't see a reason why it wouldn't be. Not 0. And break. Man, I don't love this code. But it's probably perfect. Nope. Wait, that can't be right. Oh, yeah, it can't be right. That's fine. Yeah, these all have a lot of symmetry too, so... I'm absolutely certain they're not asking for that. Why is my grid this size? Oh, because I wrote my code bad is the reason why. Thank you for asking. No, it was right. Wait, it was right, you motherfucker. If height is 4. Zero and 1. Is this not a left shift? I'm really confused. That should just be a list of zeros, yep. Is this construction just not working? Okay, well, I don't need all that now. I mean, it's faster. Is it fast enough? The answer's no. If it can't do 12 by 5, it sure as fuck is not going to do 50 by 50. I'm kind of shocked that part 1 is this nasty. I'm sure that there is a simple way to approach this that I'm just not thinking of, but, the problem is, I can tell you what the problem is, because I realized this was going to be a problem from the beginning, but I couldn't think of another solution. And the problem is that I'm doing a lot of really redundant checking. Sorry, I did not mean to... I do not know how loud that would turn out. I apologize. Generally, this class of tile solver algorithm... Wait. Class of tile solver algorithm. I mean, this is a type of packing problem, is what this is you have shapes that you're trying to pack into a grid. This is a type of problem that's typically referred to as a packing problem. There are a lot of different types of packing problems. Not all packing problems look like this one. The only thing I can think of is... I hate to keep beating this drum, because it does not always fix your problems. But I wonder if you can memoize the grid. Right, because this has overlapping sub-problems. And so memoization is the typical strategy to reduce your search space for dynamic programming. So, I just want to see if this does anything to even the first sub-problem here. And of course it doesn't. This has a lot of redundant sub-problems, though. But your search space would be so big. Do you want to know how big your search space would be? Yes, I'm saying memoization. It is a CS term for basically remembering the solutions to subproblems you've seen. Well, considering these problems are floating in the space of 50 by 50 at its largest, then you're talking about a problem space that if you enumerated all possible states, you're talking about 2 to the 2,500th power. If you memoize, don't you run into subgraph isomorphism thing trying to locate your memo in the grid? Well, the idea is that if you store your state space properly, you don't care how you arrive there. Like, imagine that you're trying to solve a maze, and the question is like, how many different paths through the maze are there? And so, what I'm going to do is, at every single location in the maze, I'm going to solve it from that position, and then when I come back, I'm going to mark that cell as, hey, just so you know, there is a solution from this spot. if I take an entirely different path and I arrive back at that location, I now don't have to solve any further because I know from that spot there is a solution. And so I can save myself the costly search to do so. I don't care how I arrive there. I'm not interested in whether or not that solution's unique from this solution. They're not. They're just sub-problems for which I've already solved. The problem is my state space is far too large here. This is yet another problem where there is a key observation that if I sat here and really thought about the problem, that key observation would probably make it very easy to solve, but I'm not sure that I see the key observation here. I'm gonna think about this for a few more minutes, and then if I don't come up with anything, I'm gonna go play video games, because I don't feel like doing this all night. There's an observation here that speeds things up. What if I only allow the next... What if rather than trying to place all of a single package first... So right now what I'm doing is I'm trying to place all of package 0, then all of package 1, then all of package 2, and so on. What if instead of doing that, I allow myself to place any package, but, importantly, it always has to be touching another package. So I don't allow myself to just search infinitely in the grid, because any situation I might find myself in which I leave a gap, I could just remove the gap. This would at least reduce the size of my search. Okay, let me try to code that up. And if I can't get this working, I'm probably going to punt on this problem for now. Um... This math isn't making sense to me. I think that works. I don't... No way that's still slow. I severely constrained my search space here. Right? Right? If this is going to take a more involved solution than this, I'm not willing to code it up right now. I'm just not. So basically what I'm doing here is I'm keeping track of like what portion of the grid I've actually used up to this point. And I'm not allowing myself to place any pieces outside of... considerably outside of that range, right? So previously, I had this giant grid. You know, it was... you can think of it like this, right? This giant grid. And I would try putting a package, you know, right here. I would try putting a package right here. But, like, the very first package, I would try it everywhere. I would try putting it here, and I would try putting it here, and I would try putting it here. I would try every location for this package. Every configuration of it, every rotation of it, everywhere on the grid. And now I'm saying, hey, if the package you're placing isn't within this constrained area, like, don't put it there. I'm saying keep it close to the edge. I get the right answer, but I'm not getting it really any faster. I tried most of the usual strategies I would try here. The only additional improvement I think I could make is if I only tried locations that are neighboring existing pieces, which this still has a bit of an issue with blowing up. Like if you imagine a degenerate case where it places packages horizontally and then switches to placing packages vertically, it's now created a large rectangle that it accepts packages within. But if I only allow myself to place in locations that are directly adjacent to other packages, which ironically is way easier for me to do with the version of this code I started with, the version of the code where I was storing it, all the filled locations as a set, rather than as a bit string. Yeah, the problem is at this point, most of the strategies I can think of that would improve this, are probably equivalent computationally to what I have now. Like, they wouldn't be faster. They'd be, like, perhaps more elegant, but I don't think they're asymptotically faster. Alright, well. I am allowing myself to tap out now. I'm out. So that is, of the 24 points available to me in Advent of Code 2025, I'm piecing out on 3 of them. You're surprised nobody spoiled this one. That is an auspicious message to send as your first message in chat. An ill portent, if you will, of the future. I would say, statistically speaking, the type of person who types that as their first message into chat barely makes it past their second message in chat.